At the foundation of matter, there is nothing that holds still. This is not a metaphor, and it is not a poetic reframing of what science has found. It is the literal content of the most precise measurements anyone has ever made. And it changes the shape of something that many people quietly are reaching for. There is a kind of stillness that the word vibration carries as a promise, a steadiness that could be entered in the morning and held, unbroken, through the whole of the day. Raise your vibration, stay in it, live there. The phrase has been circulating for years now, borrowing from the vocabulary of the laboratory, borrowing the gravity of the quantum age, offering itself as a fact about how the world works and what a person can do within it. The strange thing, the thing almost no account says plainly, is that the physics underneath the promise says something entirely different, something more demanding, something that refuses to comfort. At the bottom of everything that seems solid, there is only trembling. Nothing holds still. Nothing ever has. The want for a steady state is old. Every tradition that has ever tried to describe the good life has somewhere near its center a name for the thing being reached for, the one condition that once entered would not slip. People have sought it through breath, through prayer, through cold water and cold air, through the hour before first light when the world is thinnest. Something in the body knows what it is reaching for, a clarity without edge, a ground that does not shift with the weather of the day. You have felt the morning thin, the quality of something that was there when you woke, a kind of ease, a transparency, and was not there by noon and did not come back by wanting it back. That is the texture of the problem, not a spiritual failure, not a question of method, the not staying, the structure of what a good state is and what it will and will not do. The paradox is this: the thing being reached for is exactly the shape that reality does not take. At every scale where anyone has looked with precision, matter refuses to rest. The closer the measurement, the less stillness it finds. Not a little less, categorically less. All the way down, in every direction, at every depth the instruments can reach. There's only the oscillation, the field in motion, the activity that has no floor. At night, lying in the dark, the body has weight. The mattress holds it. The walls hold the room. The floor holds the walls. And somewhere beneath the floor, the earth holds everything, patient and unmoving, the way ground has always seemed to hold. This is how the world presents itself: solid beneath solid, depth beneath depth, all the way down. For almost the whole of human history, that presentation was simply true. True enough to build on, sleep on, trust without once asking what lay beneath the lowest layer. Then slowly, over a single century, physics took the floor apart. It began with the smallest things. The atom, once imagined as the last indestructible grain, the irreducible unit that would not divide further, turned out to be almost entirely empty. Not almost. Overwhelmingly. Scale the nucleus up to the size of a marble, and the nearest electron would orbit at the far edge of a cathedral, with nothing between them. Nothing compressed into a smaller space. Nothing dissolved into a fine mist. Nothing at all. The solidity of the table beneath a hand is not the solidity of stuff packed tight. It is the solidity of fields, unmeasurable by touch, invisible, holding patterns in place across distances that are, at their scale, enormous. The hand does not touch the table. It approaches the table, and the fields meet and refuse to pass through each other. And what that feels like, from the inside of a hand, is solid ground. Nothing is solid. Nothing all the way down is what it seems. This much has become almost familiar. It appears in popular books in the kind of late-night conversation that ends in a pleasant vertigo. The world is mostly empty space, and then the morning comes, and the floor holds, and the vertigo fades, because the day will not wait for the philosophy to settle. But this is the shallow version. The deep version does not stop at empty space. When physics looked more carefully at what remained, at the electron, at the particles that were supposed to be the final, irreducible things, it did not find things. It found something more like motion without a mover. Not a tiny object vibrating, but the vibration itself, with nothing solid at its center doing the shaking. The electron is a ripple in a field, a quantized excitation of a field that fills all of space, the way a sound wave is a disturbance in air without being a thing, except that here, unlike air, there is no medium beneath the wave. There's only the field. So is the light crossing a room right now. So is the matter of any hand that has ever reached for a steady morning. All of it, at the deepest level the measurements can reach, is excitation in fields that do not rest. This is not a philosophical position. This is quantum field theory. The framework that underlies every microchip, every laser, every precise prediction physics has produced in 70 years of testing. And what it says, stripped to its content, is that the basic fabric of the universe is not objects. It is process, not things vibrating, just the vibration all the way in, with no solid thing found at the center. The surface of substance turns out to be the only substance there is. And here the word arrives, the borrowed one. It is often said that everything vibrates at a frequency, and that the practical conclusion is to raise one's own, to climb, by intention or practice or the right thoughts, to a higher vibration and remain there. The phrase has the shape of a physical fact. It borrows the right vocabulary. It sounds like something the laboratory confirmed. What physics actually says is something both simpler and far less convenient. Yes, at the foundation, matter is vibration. That part is precise, and it is real, and it is stranger than the slogan knows. What is not real is the next step. There's no single frequency that a human body occupies. There's no scale running from low to high along any spiritual axis. The body is warm, and warmth is exactly the condition that dissolves quantum coherence at biological scales, a fact that will become important. And in the one physical law that binds energy directly to frequency, higher frequency means higher energy, and past a certain threshold, that means the radiation that passes through tissue and breaks it, not the clarity people are hoping for. The slogan takes two things that share one word, the measured oscillation of a quantum field and the felt quality of a good inner state, and calls them one thing. They are not the same thing. The truth underneath is worth more than the slogan, and the rest of this is an attempt to say what that truth actually is. So what is the honest picture? Not the empty space version, not the borrowed claim. The honest picture is this: even the nothing between things is not still. The vacuum, the empty space that is supposed to be the absolute zero of the physical world, the floor beneath the floor, turns out to have structure, to fluctuate, to seethe with activity that cannot be turned off even at the lowest temperature the universe permits. Two metal plates held in near-perfect emptiness will be pushed together by the activity of the space between them. The prediction was made in 1948. It was measured in a laboratory in 1997. The nothing between things presses on things. The vacuum hums. There's no level, no depth, no foundational layer at which the trembling stops and stillness takes over. There's no resting surface anywhere in the structure of things. You wanted a ground that held still. The ground was the first thing physics gave up. This could be heard as a kind of loss. The architecture gone, nothing to stand on. And yet, long before there were instruments precise enough to measure the pressure of the vacuum or the frequency of a particle's oscillation, there were people who arrived at the same edge by a completely different road. They had no apparatus. They had silence, and years of it. They sat and turned attention inward, and waited for the mind to hold still. And it would not. They reached for the clear and steady state, the way anyone does, and found that no state they could grasp would remain. The good morning thinned by noon. The calm dissolved the moment they tried to preserve it. What they held warmed and cooled like everything else, slipping through the reaching. For most people, then as now, this is a private failure, evidence of insufficient practice, proof of doing it wrong. But a few of them, scattered across very different centuries, in languages that would never meet, turned and faced the not holding directly, and found something in that place that they would spend the rest of their lives trying to describe, not the obstacle, the doorway. These are two roads, and they are not the same road. One is built of mathematics and apparatus, of measurement repeated until the universe answers back in numbers that can be tested and retested until the testing becomes certainty. The other is built of sustained inward attention, of stillness practiced until something in the act of watching itself changes. One belongs to the laboratory. The other belongs to a different kind of discipline entirely, with its own methods and its own standards for what counts as knowing. They do not prove each other. The physics does not validate what the contemplatives found, and the contemplatives do not validate the physics. To claim they do is to misunderstand both, and there are many who are eager to make that claim, because the claim is comfortable and sells well. The traditions will appear here later, named with their specific centuries and their specific texts, and the structural resemblance between what they describe and what the instruments have found will be held with great care and not collapsed into proof. The languages are different. The methods could not be more different. What is being held open is only this, that two roads, by different means, reach the same edge. The same discovery that the solid was the surface. That depth is process, not possession. That the stable ground people have been reaching for was always something that the fabric of things does not contain. The account of how physics reached that edge begins in an unlikely place, not at a particle accelerator, not at a telescope trained on the edge of the universe. In a room with a heated oven in Berlin, at the turn of the 20th century, with a problem about the color of heat that refused, for years, to behave. A theoretical physicist named Max Planck was trying to make the mathematics of thermal radiation work. The existing framework demanded that a hot body should radiate unlimited energy at high frequencies. The ovens in every laboratory on Earth refused to do this. The mathematics insisted. The ovens held their ground. Planck spent years trying to find where the theory was wrong, and in what he would later describe as an act of desperation, not discovery, desperation, he inserted a small number into the equation, a fixed ratio between the frequency of a light wave and the energy it carries. Frequency times this constant equals energy. Always. Exactly. No exceptions. He expected to find the deeper reason and remove it. The deeper reason never arrived. The number stayed. It is in every equation that followed. like a threshold carved into the structure of the world below, which reality cannot be divided further. What the frequency of a thing and the energy it carries have to do with each other, precisely, measurably, without exception, is where the honest account of vibration begins. In the autumn of 1900, Max Planck, a German theoretical physicist working in Berlin, a man who would rather have been wrong, presented a formula to a gathering of physicists that fit the data perfectly and that he could not, at first, explain. He was not trying to discover something new. He was trying to patch a calculation that kept failing in a way that had been embarrassing the field for years. The problem was heat. Not the concept of heat, but the precise spectrum of light it produces. When a metal object is heated, when iron goes from black to red to orange to white, it radiates light, and the distribution of that light across different frequencies follows a specific curve. Physicists in the late 19th century could measure that curve with great accuracy. They could not calculate it. The existing framework, classical thermodynamics applied to the vibrating atoms in the heated material, gave a curve that matched the measurements at low frequencies and collapsed spectacularly at high ones. The mathematics predicted that a heated object should radiate unlimited energy at violet and ultraviolet frequencies. No oven in any laboratory on Earth did this. The theoretical curve went to infinity. The actual radiation did not. Something fundamental was wrong. Planck worked backward from the data. He found the mathematical formula that fit the measured curves across all frequencies at all temperatures. Then he asked what physical picture could generate such a formula. The only picture that worked required an assumption he found deeply uncomfortable. The charged oscillators in the walls of the heated cavity, the atoms radiating the light, could not emit or absorb energy continuously. They could only exchange energy in discrete packets, each packet proportional to the frequency of the oscillator. A small number, which he called h, mediated the relationship. Energy divided by frequency. Always the same ratio. The higher the frequency, the larger the minimum packet required. At high frequencies, the thermal energy available in the cavity could not supply even one packet. The high-frequency modes went dark. The catastrophe was avoided. The formula worked. The constant held. Planck called his assumption a mathematical trick, a temporary device, something to be replaced once a proper classical explanation arrived. He waited. The classical explanation did not arrive. The constant stayed, embedded in every equation that followed, a threshold below which the world cannot be divided further. The number itself is almost incomprehensibly small, 6.626, 1034 joule seconds, a ratio so tiny it is effectively invisible at any scale above the atomic. But it is there, always there, fixed into the architecture of things. What Planck had found, without intending to, was the unit of action, the smallest possible transaction between matter and radiation, not a lower limit on energy, on size, but on the product of energy and time, a quantity physicists call action, and that governs everything that happens at quantum scales. He had found the grain of the universe. He spent years hoping it would go away. It did not go away. It should be said clearly. Planck's constant does not mean that the universe vibrates at a specific frequency that human beings can match. What E. Cauchy describes is a relationship between frequency and energy at the quantum scale, applicable to the oscillating atoms and fields that make up matter and radiation, and not applicable, not meaningfully applicable, to any collection of atoms the size of a hand or a body or a room. The constant is real. Its domain is not what the popular conversation suggests. These are different things. 5 years after Planck's formula, Albert Einstein, a 26-year-old patent examiner in Bern, with no laboratory, no university position, and no one expecting anything from him, proposed something more radical than Planck had been willing to say. Planck had quantized the matter oscillators. The light itself, he had assumed, remained a continuous wave. Einstein read the data from the photoelectric effect and proposed that light was not continuous at all. That light itself arrives in discrete packets, that each packet carries an energy of exactly hn, where n is the frequency of the light and h is the same constant Planck had reluctantly introduced. One quantum of light, indivisible, absorbed whole by a single electron, or not at all. The photoelectric effect had been puzzling physicists since Heinrich Hertz noticed it in passing in 1887. Shine ultraviolet light onto a metal surface, and electrons are ejected from it. Classical physics could explain the basic phenomenon. Light is a wave. Waves carry energy. Energy liberates electrons. What it could not explain was the specific pattern. Brighter light should give the ejected electrons more energy. It did not. Brighter light produced more electrons, not faster ones. What determined the energy of each ejected electron was the color of the light, its frequency, not its brightness. And below a certain threshold frequency, no electrons were ejected at all, regardless of how much light was used. Einstein's explanation was precise. An electron in the metal is bound by a specific energy, the work function of the material. A photon arrives, carrying energy hn. If that energy exceeds the work function, the electron absorbs the photon entire and escapes. If not, nothing happens. The photon cannot be partially absorbed. There is no accumulated effect. Dim high-frequency light ejects electrons immediately. Brilliant low-frequency light does nothing. The photon is a threshold event, not a gradual process. He was not believed. The wave theory of light was one of the most thoroughly confirmed ideas in all of physics. Maxwell's equations, Hertz's radio waves, the entire edifice of 19th century electromagnetism, all of it described light as a continuous wave. Einstein himself called his proposal heuristic, a useful hypothesis rather than a confident claim. He was more careful about overclaiming than almost anyone who has ever cited him. Robert Millikan, working in Chicago in the 1910s, designed a series of experiments specifically to refute Einstein's hypothesis. He measured the relationship between light frequency and the energy of ejected electrons with extraordinary care. His measurements confirmed Einstein's formula precisely and completely. Millikan published the results, stated in the same publication that he found Einstein's interpretation difficult to accept, and was awarded a share of the Nobel Prize in 1923 for the work. Einstein had been awarded it 2 years earlier in 1921 for the same discovery that Millikan had confirmed while doubting. The result was unambiguous. Energy is quantized. The quantum of light is real. Two separate phenomena, the spectrum of a heated body, the ejection of electrons by light, had produced the same constant, the same structure, the same irreducible unit. This was not a coincidence. It was a signature. Something strange happens when an experiment designed to refute a theory confirms it. The person who designed the experiment is in an uncomfortable position. Millikan was in that position, so in a different way was the field. A century of wave optics confirmed. And now this, light comes in parcels. Both true, neither sufficient alone. The field was left holding a contradiction it could not resolve, and would not resolve for another 20 years. 11 years after Einstein's 1905 paper, a French doctoral student named Louis de Broglie, working at the Sorbonne, in a thesis his advisors were uncertain how to evaluate, turned the problem around. If light, classically a wave, arrives as discrete particles, then perhaps matter, classically discrete, propagates as waves. If photons have a frequency and a wavelength set by their energy, then perhaps electrons do too. Perhaps everything does. The de Broglie relation, proposed in 1924, is a single equation, L equals h divided by p, where L is the wavelength associated with a particle, h is Planck's constant, and p is the particle's momentum. Correspondingly, the frequency is E divided by h, the energy of the particle divided by the same constant. Every massive particle carries an associated wavelength and an associated frequency, determined entirely by its mechanical state, not metaphorically, not as a manner of speaking, as a physical fact, testable in a laboratory. De Broglie's committee was unsure. They sent the thesis to Einstein for an opinion. Einstein wrote back that it was interesting enough to pursue. The degree was awarded. De Broglie had proposed the matter wave, and he now needed someone to find it. The confirmation arrived in 1927 in a laboratory at Bell Telephone in New York through an accident. Clinton Davison and his colleague Lester Germer had been studying how electrons scatter from nickel surfaces when a vacuum tube in their apparatus broke, exposing the nickel sample to air and requiring the apparatus to be heated to clean it. The heating caused the nickel to crystallize into large facets. When they resumed the experiment, the scattered electrons no longer distributed smoothly in all directions. They concentrated in sharp peaks at specific angles. The pattern was unmistakable. It was the same pattern that X-rays make when diffracted through a crystal lattice. Waves interfering constructively at angles where the path length difference equals an integer multiple of the wavelength. Diffraction. The electrons were diffracting. They had a wavelength. The wavelength matched de Broglie's formula exactly, to within the precision of the measurement. At almost the same time, George Paget Thomson, working in Aberdeen with electrons passed through thin gold foil, produced the rings of a diffraction pattern on photographic film, the same concentric circles that light makes passing through a grating, now made by matter. J. Thomson, his father, had won the 1906 Nobel Prize for proving the electron is a particle. George Thomson shared the 1937 Nobel for proving it is a wave. Neither committee was wrong. The electron is not adequately described as either alone. You have held a prism and watched white light break into its component colors, each frequency bending at a different angle, each wave following its own path through the glass. The diffraction of electrons through a crystal is the same geometry, the same wave mechanics, producing the same angular structure, but with waves whose wavelengths are determined not by color, but by mass and speed. Matter finding its way through a lattice, the way light finds its way through a prism. The architecture is the same. The substance is different. So is the scale. The de Broglie wavelength of a person walking across a room is roughly 10 to 35 meters, far smaller than any known structure in the universe that could diffract it. The matter wave of a human being is not a mystical vibration moving through space. It is a mathematical quantity below any physical relevance at human scales. The wave is real at quantum scales. At human scales, it is not absent. It is simply smaller than everything that could detect it. these are not the same as being the same. De Broglie's insight immediately illuminated something Niels Bohr, the Danish physicist who first modeled the hydrogen atom, had left unexplained in 1913. Bohr's model of the atom was a triumph. It predicted the spectral lines of hydrogen with startling accuracy, placing electrons in specific orbits at specific energies. But it provided no reason for why those orbits and not others. Bohr had simply declared the allowed orbits without a mechanism to produce the discreteness. De Broglie supplied the mechanism. An allowed orbit is one where the electron's matter wave fits as a standing wave around the nucleus. The circumference of the orbit must equal an integer multiple of the electron's wavelength. 1 wavelength around, 2, 3, the resonant modes. Any other circumference would produce destructive interference, the wave canceling itself as it completes the loop, and no stable pattern would persist. Only the resonant orbits survive. This is the principle of the plucked string. A string stretched between 2 fixed points can vibrate at frequencies whose half wavelength fits into the string's length an integer number of times. The first mode, the second, the third, the harmonic series. No others. The string is bounded, and only modes that fit the boundary survive. The hydrogen atom's allowed orbits are its harmonic series. The spectrum of hydrogen, the precise frequencies of light it emits and absorbs, is the chord the hydrogen atom plays, determined by the geometry of standing waves. Erwin Schrödinger, working in Zurich in 1925 and 1926 in a period of creative intensity he would never quite repeat, generalized de Broglie's wave into a proper differential equation, the wave equation that bears his name. The Schrödinger equation governs the evolution of a complex-valued function, the wave function, that is defined at every point in space and changes with time according to fixed mathematical rules. The wave function is not directly observable. Its square gives the probability of finding a particle at a given location if a measurement is made. The allowed energy levels of the hydrogen atom are the values for which the Schrödinger equation has stable, normalizable solutions, the wave functions that do not blow up at large distances, that describe a wave self-consistently confined. The electron in its ground state is not a particle orbiting a nucleus like a planet around a sun. It is a probability wave shaped roughly like a sphere, peaked near the nucleus and falling off with distance, oscillating at its lowest allowed frequency. It is stable not because something is holding it in place, but because it is the fundamental mode of its bounded cavity. The atom is a resonator. Its spectrum is its natural frequencies. Physics discovered this from the outside, through spectroscopy, long before it understood the geometry of what it was measuring. By 1926, the mathematical framework of quantum mechanics was essentially complete. Schrödinger had his wave equation. Werner Heisenberg had independently arrived at an equivalent formulation using matrices. Paul Dirac demonstrated that both were expressions of a single underlying algebraic structure. 3 people, by different roads, had found the same architecture. The convergence was evidence. Inside the Schrödinger framework sits a single model of such generality that it recurs in modified forms in almost every domain of physics. The quantum harmonic oscillator, a particle confined in a parabolic potential, the simplest possible trap. Its allowed energies are not continuous but discrete. They are n plus 120, where n is 0 or a positive integer. O is the natural frequency of the trap, and is Planck's constant divided by 2p. The ground state, with n values 0, has energy 120, not 0. The system cannot be completely still. This is the Heisenberg uncertainty principle, expressed as a physical constraint. If the oscillator were at rest, position exactly at the bottom, momentum exactly zero, both quantities would be simultaneously known with perfect precision. The uncertainty principle forbids this. The ground state retains an irreducible motion, the zero-point energy, the minimum trembling that the structure of quantum mechanics requires. The oscillator cannot be brought to rest. It can be cooled toward the ground state. But the ground state is not silence. It is the quietest the physics permits. The algebra of the harmonic oscillator is built on two operations, one that adds a single quantum of energy to the system, one that removes one. These are the creation and annihilation operators, raising and lowering, the ladder of discrete energy steps. They are the mathematical ancestors of the field operators of quantum field theory. Every interaction in the standard model of particle physics is written in terms of operators descended from the ladder of the harmonic oscillator. The simplest quantum model contains the algebraic skeleton of all of quantum field theory. Paul Dirac, working at Cambridge in 1927, took the step that changed the picture entirely. He had already given electrons their relativistic equation, the Dirac equation, which combined quantum mechanics with special relativity and correctly predicted properties of the electron that no previous theory had touched, including its spin and the precise strength of its magnetic response. But in 1927, his attention turned to the electromagnetic field itself. He asked how to apply the quantum rules, discreteness, probability amplitudes, the algebra of the harmonic oscillator, not to a particle, but to a field. The answer was, treat each mode of the electromagnetic field as an independent quantum harmonic oscillator. The photon is not a particle separate from the field. It is one quantum of excitation, one rung up the ladder, in a mode of the field. The field is everywhere, filling all space, and its ground state is not empty, but seething with the zero-point energy of all its modes. A photon is a localized excitation of the photon field, the way a ripple is a localized disturbance in a body of water, except that here, there is no water being disturbed. The field is not a medium. It is the fundamental thing, and the ripple is what we call a particle. The same quantization was extended, over the decades that followed, to every other known field. The electron has a field. The quarks each have fields. The Higgs boson has a field. There are, in the current best theory of particle physics, 17 fundamental quantum fields. Every particle in the universe, every electron, every photon, every quark, is a localized excitation of one of these fields. Not an object in a field, an excitation of the field itself, with no further substance behind it. This has a consequence that takes time to absorb. When the statement is made that everything is vibration, it can be heard as metaphor, a poetic way of saying things are dynamic, impermanent, changing. In quantum field theory, the statement is closer to literal. The electron is not a particle that sometimes vibrates. The electron is a mode of oscillation of a field. The oscillation is not something the electron does. The oscillation is what the electron is, and the field it oscillates in has no substrate. There's no medium being waved, no ether through which the disturbance propagates. The field is the bottom. The excitation is the electron. There is nothing further to point at. The theory built on this picture has been tested in ways that have no parallel in the history of science. The magnetic moment of the electron, a measure of how strongly it responds to a magnetic field, is predicted by quantum electrodynamics, the quantum field theory of the electromagnetic interaction to 1 part in a trillion. The measurement agrees. This is not a rough confirmation. It is an agreement between theory and experiment at a precision that dwarfs any other quantitative prediction in physics. The framework is confirmed. The picture of fields and their excitations is not a hypothesis awaiting further evidence. It is the best established description of matter that exists. The standard model that emerged from this framework over the subsequent decades describes 17 distinct quantum fields, 6 quark fields, 6 lepton fields, including the electron, 4 gauge fields carrying the fundamental forces, and the Higgs field, which interacts with the others to produce mass. Every material object in the universe, every stone, every breath of air, every cell in every body, is composed entirely of excitations of these 17 fields, interacting through the exchange of additional field excitations at their boundaries. There is no level of the description where objects appear. There is only field excitation all the way in, coupling and propagating according to rules that have been tested against experiment at particle accelerators in Geneva and Chicago and Stanford for more than half a century. The rules hold. Nothing has broken them. The edifice of quantum field theory stands as the most precisely confirmed structure in the history of human inquiry into nature. There is something worth sitting with before going further. The picture being assembled is not that reality is made of little things that happen to vibrate. It is that the vibration and the thing are not separable. The oscillation is not what things do. It is what things are. There is no electron to which a wave has been assigned. There is only the field excitation, and the excitation is the electron, with nothing further beneath it to locate and call the substance. Each quantum field has a ground state, the state of minimum excitation with no particles present. In quantum field theory, this is the vacuum, the empty space from which everything else arises and into which everything returns. And the vacuum ground state is not nothing. Each mode of each field contributes a 0-point energy of 120, the same irreducible minimum as the quantum harmonic oscillator. Sum over all modes of all fields, over every frequency, every direction, every polarization, and the total is formally infinite. Quantum field theory handles this by renormalization. The infinite constant is subtracted, and only the differences in vacuum energy between different regions of space are taken as physically meaningful. The differences are real. They are measurable. Hendrik Casimir, a Dutch physicist working at the Philips Research Laboratories in Eindhoven, predicted in 1948 that the structure of the vacuum would produce a measurable force between 2 parallel uncharged conducting plates placed close together in a vacuum. The mechanism is precise. Between the plates, only those vacuum modes whose wavelength fits an integer number of times between the plates can exist. Outside the plates, all modes are present. The restricted set of modes between the plates carries less 0-point energy than the unrestricted vacuum outside. This difference creates a net inward pressure. The nothing between the plates pushes the plates together, not because of any charge or thermal effect, but because of the asymmetry in the vacuum's own ground state structure. The force is small. For plates separated by a few hundred nanometers, around 1/1,000,000th of a Newton per square centimeter. But it scales with the 4th power of the separation, a precise signature with no classical analog. Casimir's prediction stood for nearly 50 years before it was tested with the precision required to confirm it. In 1997, Stephen Lamoureux at the University of Washington measured the force between a flat plate and a polished sphere using a torsion pendulum.
a fiber twisted by forces so small they are normally invisible. His measurement agreed with Casimir's calculation to within 5%. Subsequent experiments using atomic force microscopes with better control of surface geometry have confirmed the effect with greater precision. The force is not hypothetical.
It has been engineered, used in the design of microelectromechanical systems, and reproduced in dozens of laboratories. The vacuum is not empty. This sentence is not a figure of speech. It is a measured fact. The ground state of the quantum fields that fill all of space has energy, structure, and measurable effects on anything immersed in it. Every particle in every atom in any material object is immersed in this ground state. The vacuum's activity is not detectable to human senses, not because it is too subtle to be real, but because everything is equally immersed in it, and there is no reference state that is emptier. Here is what remains unsettled. The Casimir force is confirmed. The 0-point fluctuations are confirmed. What is not resolved is how the vacuum's total energy density relates to the cosmological constant. The term in Einstein's equations that represents the energy of empty space and governs the expansion of the universe. The quantum field calculation of the vacuum's total energy density overshoots the measured value by somewhere between 60 and 120 orders of magnitude, depending on where the calculation is cut off. This is the largest quantitative failure of a physical theory in the history of science. The vacuum hums, measurably, at the scale of metal plates in a laboratory, and no one can account for why the universe does not collapse or expand into infinity under the weight of that humming. In 1930, Erwin Schrödinger, who had already given quantum mechanics its wave equation, and who was by then in a long and unresolved argument with Bohr and Heisenberg about what the wave function actually described, found something he had not been looking for. He was analyzing solutions of the Dirac equation, exploring what the relativistic treatment of the electron implied for its spatial behavior, and he found embedded in the algebra an unexpected prediction. A free electron, not bound in an atom, simply moving through space, should undergo a rapid, persistent oscillatory motion superimposed on any average velocity. Not a smooth path, a trembling path. He called it Zitterbewegung, the German word for trembling motion. The mechanism is structural. The Dirac equation's solutions are superpositions of states with positive and negative energy. These components do not travel together. They interfere, and their interference produces a rapid oscillation of the electron's calculated position around its average trajectory. The frequency of the trembling is fixed by the electron's rest mass energy, approximately 2.5x, 10^20 oscillations per second. The amplitude is on the order of the Compton wavelength of the electron, about 2.4x 10 to 12 meters, 2,000 times smaller than the diameter of a hydrogen atom. The electron's most solid physical characteristic, its position in space, oscillates at a frequency so high and an amplitude so small that no instrument yet built can observe it directly in a free electron. The Zitterbewegung is not an artifact of bad calculation. It follows from the structure of the Dirac equation, the same equation that predicts the electron's magnetic moment to 1 part in a trillion. In 2010, René Gerritsma and a team at the University of Innsbruck built an analog of the Dirac electron using a single trapped calcium ion, held in an electromagnetic field with lasers. The ion's motion represented the electron's spatial position. The internal quantum states of the ion represented the positive and negative energy components of the Dirac solution. When the team prepared the ion in a superposition of these states,
the analog trembling appeared in the ion's motion, exactly as the Dirac equation predicted. They watched it oscillate in real time, with the precision of laser spectroscopy. The geometry was confirmed.
The honest position is this. The Innsbruck experiment confirmed the mathematical structure of the Dirac equation's prediction, not a physical trajectory of a real electron in free space. Whether the Zitterbewegung describes an actual path of the electron, or whether it is a property of the wave function rather than a real motion, depends on which interpretation of quantum mechanics one takes. In Bohr's standard formalism, the electron has no trajectory between measurements, and the trembling is a feature of the probability amplitude. In David Bohm's pilot wave interpretation, the electron has a definite path, and the trembling is a real spatial oscillation. Both interpretations predict the same experimental results. Neither has been ruled out. The trembling is not in doubt. What is in doubt is what it means for the electron to tremble. By the middle of the 20th century, the scientific foundation was in place, not complete, not finally interpreted, but established, a set of quantum fields permeating all of space, particles as field excitations, energy bound to frequency through an irreducible constant, matter with wave character confirmed in the laboratory, the vacuum with measurable structure, atoms stable because their electron waves resonate in their lowest allowed modes. And at the bottom of it all, in the relativistic equation for the most familiar particle, in the quiet mathematics no one questions, an oscillation so small and so fast that it cannot yet be directly seen, but that falls out of the theory as naturally as the prediction of the positron, as naturally as the magnetic moment measured 1 trillion times and confirmed. The picture is solid at its surface. The foundation holds, and yet, within the same equations, the same confirmed framework, there are questions the foundation has opened and cannot close. The vacuum's energy that should weigh the universe and does not. The collapse of the wave function that the mathematics shows without explaining. The gap between the superposed quantum state and the definite classical world. A gap that decoherence describes in formal language without fully resolving, and that has remained, quietly, at the center of physics for 90 years. There are scientists who have looked at these questions and decided they are not real questions, that the mathematics works, the predictions hold, and asking what it all means is philosophy rather than physics. There are others who have spent careers on the questions and who hold the view, not unreasonably, that a theory whose foundations are unresolved is a theory not yet understood. Both camps have continued to accumulate experimental confirmation. Neither has closed the argument. The tools that produce the most precise physical predictions in history have not produced an agreed account of what the world is like when no measurement is being made. The surface is confirmed. The depth is not resolved. And the deeper the measurement reaches, the more clearly the depth is there, waiting, not as an embarrassment to the framework, but as the most interesting thing about it. For almost a century, the question has been sitting inside the mathematics, quietly and without apology. The Schrödinger equation is deterministic. Given any quantum state at one moment, it produces a precise description of that state at every moment after. It never fails. Its predictions are among the most accurate in the history of science. And in every application, every calculation, every designed experiment, the equation does exactly what it should do, until the measurement. At the moment of measurement, when an instrument registers a position, when a detector fires, when a photon arrives at a screen, a definite outcome appears. A particle is found here,
not spread across its probability cloud. The detector clicks once in one place. The superposition resolves into a single fact. The equation says this should not happen, not because the equation is wrong,
but because the equation describes a smooth, continuous evolution, and a collapse from superposition to single outcome is not smooth or continuous. It is a jump, a discontinuity, something the formalism accommodates in practice with a rule called the collapse postulate, but does not explain in principle. The collapse postulate says, upon measurement, the wave function collapses to one of its possible outcomes, with probability given by the square of the corresponding amplitude. It works. It gives the right numbers every time. It does not say what a measurement is. It does not say what counts as one. It does not say why the same mathematics that works everywhere else is simply suspended at the moment it is invoked. This is the measurement problem. It is not a minor technical detail. It is a fracture at the center of the most successful physical theory in history, and the physicists who have taken it most seriously, who have refused to file it away as a bookkeeping question, have found that it leads somewhere very strange. The problem was recognized immediately. Schrödinger wrote his cat in 1935, not as a riddle for popularizers, but as a pointed objection to Bohr's reassurances, a protest against the claim that the strangeness could be confined to the laboratory and safely ignored above a certain scale. Werner Heisenberg and Niels Bohr gave one set of answers. Albert Einstein and Schrödinger gave different ones and were largely set aside. The debates ran for decades in letters and seminar rooms and ended not in resolution, but in the practical dominance of a position whose proponents declined to say what it meant. The strangeness was present from the beginning. It has not diminished with time. The first serious attempt to address it came from Wojciech Zurek, a Polish-American physicist working at Los Alamos National Laboratory through the 1980s and 1990s. Zurek did not claim to solve the measurement problem. He claimed to dissolve its most visible symptom. The symptom was this: quantum mechanics predicts that large systems, detectors, instruments, cats, human brains, should exist in superpositions of macroscopically different states. Schrödinger himself dramatized the point with the thought experiment of the cat in the box. A quantum event is connected to a mechanism that will kill the cat if the particle decays. The particle is in a superposition of decayed and not decayed, so the mechanism is in a superposition. So the cat, by the same logic, should be in a superposition of alive and dead. But no cat is ever found that way. Every measurement gives one outcome. Every cat is one thing or the other. Zurek's decoherence theory explained why. Nothing is isolated. Every macroscopic object interacts continuously with its environment. Photons scattering off it, air molecules colliding with it, electromagnetic fields coupling to its charges. Each interaction entangles the object with the environment. An entanglement disperses the quantum superposition into the enormous complexity of the environment's degrees of freedom, where it cannot be recovered. The interference terms, the mathematical signature of superposition, the terms that make quantum mechanics different from classical probability, survive in the combined quantum state of object plus environment, but they are inaccessible. To observe the interference, one would have to track and control every photon in the room, every air molecule, every vibration. Under any realistic conditions, this is impossible. The timescales are unimaginably short. For a grain of dust at room temperature, the decoherence time is approximately 1023 seconds. For a large biological molecule, somewhat longer. For an object the size of a person, The superposition has been effectively destroyed before any physical process could notice it. You have stood in a room and simply looked at a chair. The chair was there, definite, one place, not superposed across the room. This is not because the chair's atoms obey different rules than an electron in a physics lab. It is because the chair has been in continuous contact with the air and light and floor for as long as it has existed. Its quantum state has been measured continuously by its surroundings. The measuring is so fast, so total, that what remains is a classical object in a definite place. Cold is the friend of coherence. Warmth destroys it. This is the precise reason quantum computers must be cooled to temperatures near absolute zero, to protect the delicate superpositions from the thermal noise that would instantly decohere them. And it is why the quantum nature of matter, real, confirmed, and strange, has no direct implication for what happens in the thermal, wet, warm, constantly colliding biological body. What Zurek showed is clean. The appearance of classical definiteness at everyday scales follows from the quantum formalism, without any additional postulate, once the environment's role is properly included. The classical world is what quantum mechanics looks like from the inside, after the environment has been doing its measuring work unceasingly and at an almost incomprehensible rate. There is a kind of relief in a good explanation. Schrödinger's cat is resolved. The chair stays solid. The world works the way it looks like it works. Decoherence is, within its domain, genuinely beautiful. A theory that explains the apparent classicality of everyday life without adding a single new postulate to quantum mechanics. The standard story could stop here, tidied up and closed. And then the question that decoherence cannot answer surfaces, quietly from underneath. Decoherence explains why we see a definite outcome rather than an observable superposition. It does not explain which definite outcome we see. This distinction is small and enormous. After decoherence, the mathematics still contains all possible outcomes. The global wave function of particle plus instrument plus environment is still a superposition. The branches have been separated, made orthogonal, entangled with distinct environment states, stripped of their ability to interfere. But they are all still there, in the mathematics, at the same time. Decoherence produces something that looks like classical probability from the inside of any one branch. It does not produce a single branch. John von Neumann, the mathematician who gave quantum mechanics its first rigorous foundation in 1932, showed that this is not a problem the formalism can cure from within. He traced the chain of entanglement from particle to instrument, to recording device to observer, and showed that the chain can be pushed back without limit. No matter how far up the measurement chain you go, particle, detector, photographic plate, retinal cell, neural signal, conscious experience, the quantum formalism describes the entire chain as a superposition. There's no cut, no place where superposition ends and fact begins. The collapse postulate must be inserted by hand. Eugene Wigner, working at Princeton in the 1960s, made the implication explicit with a thought experiment. Wigner's friend is inside a sealed laboratory, conducting a quantum measurement. She observes a definite outcome. From inside the lab, she has a fact. From outside, Wigner, who has not opened the door, can in principle describe the entire laboratory, including his friend and her measurement result, as a quantum superposition. Both descriptions are internally consistent. They are not the same description. Something must break the symmetry between inside and outside. Wigner suggested that it might be consciousness. And here the popular version of quantum mechanics goes seriously wrong. It is often said that quantum mechanics proves that consciousness creates reality, that the act of conscious observation collapses the wave function and brings definite facts into being. This is among the most widely repeated misreadings in popular science, and it rests on a confusion of two meanings of the same word. The word is observer. In quantum mechanics, an observer is not a mind. It is any physical system that produces an entangled record of an interaction. A camera is an observer in the quantum sense. A photographic plate is. A grain of photosensitive material is. The formalism does not ask whether the system is conscious. It asks whether a physical record has been established in the environment. Quantum eraser experiments have shown that this kind of observation can be reversed if the physical record is erased before any measurement of it is made, which would make no sense if conscious attention were responsible for the collapse. The formalism is indifferent to awareness. The measurement problem is not a problem about minds. It is a problem about what physical process, in a deterministic and linear theory, produces the appearance of definite single outcomes. Inserting consciousness solves nothing. It adds a second unresolved question to the first. That first question is genuine. It is open. It is unsolved, not because no one has looked, but because every serious attempt to look has confirmed that the problem is real and that the solution is not obvious. This is what 90 years of careful work has established. What is established is this: the quantum formalism is consistent, confirmed, and produces correct predictions with extraordinary precision. Decoherence explains why the macroscopic world appears classical. Something called measurement produces definite outcomes at the statistics the formalism predicts. What remains genuinely open is what physical process constitutes a measurement, why one outcome is selected rather than another, and what the relationship is between the global quantum state, which contains all outcomes, and the single outcome that appears in the laboratory and in experience. The question is real. It is not going away. Every generation of physicists has either taken it seriously or decided to set it aside in favor of calculation. Both strategies have been productive. Neither has resolved the question. The responses to this open question have generated a set of proposed interpretations. Each is logically consistent. Each reproduces every experimental prediction of quantum mechanics. None has achieved consensus among physicists after 70 years of serious discussion. Copenhagen, the position associated with Niels Bohr and Werner Heisenberg, says the question is malformed. Quantum mechanics is not a description of reality. It is a tool for predicting measurement outcomes. The wave function is not a real physical object, but a compendium of probabilities. Asking what the wave function is really doing between measurements is stepping outside the theory's domain. This answer commands practical respect. It has guided quantum technology for nearly a century and leaves a deep philosophical dissatisfaction because it resolves the question by refusing it. Hugh Everett, a Princeton graduate student in 1957, proposed that the wave function is real and never collapses. Every quantum event branches. Every outcome occurs, each in a separate, non-communicating branch of the universal wave function. What we call our observation is the observation from inside one particular branch, with no access to the others. Physicists David Deutsch at Oxford and Sean Carroll at Johns Hopkins have developed this position with rigor and have argued that it is the only interpretation that takes the mathematics at face value without adding mechanisms that are not in the equations. The critics, also serious, also rigorous, point to the probability problem. In a theory where every outcome occurs,
where every branch is equally real, the notion of probability loses its natural grounding. Probability normally means this outcome out of possible outcomes with a certain frequency.
In many worlds, all outcomes always occur. The Born rule, the rule giving probabilities as the square of the wave function amplitude, must be derived from some other principle, and no derivation has achieved consensus. This is not a peripheral issue. It is, for many physicists, the central reason the interpretation remains controversial. The honest proponents acknowledge it. It is unresolved. David Bohm, working at Birkbeck College in London in 1952, proposed that particles are real, with definite positions at all times, guided by a pilot wave that is equally real, deterministic, non-local, free of the collapse problem. The apparent randomness of quantum mechanics arises because initial positions are unknown, not because they do not exist. Bohm's work was largely dismissed when published, partly because of political circumstances that limited its circulation, and partly because Bohr's authority in the field was then nearly total. John Bell, who would prove his famous theorem a decade later, credited Bohmian mechanics with showing him that quantum mechanics required non-locality. The interpretation remains viable, unrefuted, and out of the mainstream. Objective collapse theories, proposed by Ghirardi, Rimini, and Weber in 1986, add a physical mechanism to quantum mechanics itself. Wave functions spontaneously collapse at a very small but non-zero rate per particle. For a single particle, collapse is rare. For a macroscopic object with 1023 particles, it is effectively continuous. No observer needed. The collapse is a real physical event, added to the formalism as a new law. These theories are in principle testable. They predict slightly different interference behaviors for massive objects. No clear experimental signature has appeared. Carlo Rovelli, at the Centre de Physique Théorique in Marseille, proposed in 1996 that quantum states are always relational. There is no observer-independent fact about the state of a system. Facts are relative. The moon has a quantum state relative to a telescope, another relative to a distant galaxy, none that is absolute. This removes the collapse problem by dissolving the concept of absolute states. It produces its own questions about what relational facts are. No interpretation has achieved consensus. No experiment distinguishes between them. The problem is interpretive, not empirical. It is the question of what the confirmed mathematics is a map of. The map is confirmed. The territory is unresolved. There's something almost vertiginous in this. You make a choice, a small one, something ordinary. And the physics says the process by which you arrived at one option rather than another is precisely what the theory cannot account for. The theory predicts that you will choose with a certain probability. It cannot say what you was doing when the outcome became this and not that. This is not a gap in your knowledge. It is a gap in what any physics account has yet provided. The edge is here. Not the edge of the equations, which continue to work with extraordinary precision. The edge of what the equations describe when they work. At a very different scale, a different set of questions has been gathering genuine scientific attention. Whether quantum effects play functional roles in biological systems, and what this would mean. A migratory bird knows north without a compass. Something in the chemistry of its eye detects the direction of Earth's magnetic field, and the bird orientates by it in darkness over thousands of miles of open water. The mechanism, as best understood, is quantum mechanical. Cryptochrome proteins in the retina, activated by light, produce pairs of electrons with entangled spins, a radical pair.
The behavior of this spin pair is sensitive to the direction of Earth's magnetic field through a quantum mechanical interaction called hyperfine coupling.
The field alters the ratio of singlet and triplet states the radical pair occupies, which alters the chemical products that result, which the retina can in principle detect as a directional signal. This is a genuine quantum mechanical effect, electron spin entanglement, functioning in a warm, wet biological environment, doing navigational work in a living animal. In 2009, Thorsten Ritz and colleagues showed that European robins lose the ability to orient using Earth's field when exposed to radiofrequency radiation that disrupts radical pair dynamics. The evidence is behavioral and indirect. Direct measurements of quantum coherence in cryptochrome in living tissue have not been achieved, but the mechanism is specific. The physics is well specified, and the prediction that radiofrequency disruption of radical pair spin states should impair magnetoreception is distinctive enough that its confirmation is meaningful. It is the most persuasive case in quantum biology. It is not yet confirmed at the level of direct measurement. In 2007, the Graham-Fleming Group at the University of California, Berkeley, published a study of the FMO complex, a protein that shuttles excitation in green sulfur bacteria from the light harvesting antenna to the reaction center. They reported oscillations in the spectroscopic signal that persisted for hundreds of femtoseconds at room temperature, far longer than anyone expected quantum coherence to survive in a biological environment. The paper was interpreted as evidence that the excitation explores multiple pathways simultaneously in quantum superposition, achieving near-perfect efficiency through quantum coherence. The honest account is more cautious. Subsequent work, including from Fleming's own group, raised a significant concern. The observed oscillations might be vibrational rather than electronic coherences, nuclear motion rather than electronic superposition. These look nearly identical in the experimental signatures available in 2007 and can be explained classically. The question of whether the coherence is electronic and functionally significant or vibrational and incidental requires experiments that are still being refined. The dramatic version of the story overreached. A more careful version, that quantum mechanical effects may shape specific aspects of biological energy transfer in ways more nuanced than a clean quantum coherence story allows, remains a live and honest area of research. The field has become more careful, not less interested, in the years since the 2007 paper. Roger Penrose and Stuart Hameroff have proposed that quantum superpositions in microtubules inside neurons undergo an objective reduction driven by quantum gravity, producing conscious experience. This is a serious proposal from a serious physicist. The evidence is essentially absent. No demonstration of quantum coherence in microtubules at body temperature. No known mechanism for quantum gravity at neural scales. No positive experimental result. It should be named as a live theoretical proposal and assessed by what the evidence shows. The evidence shows very little. Quantum biology is real. Specific quantum effects in specific systems are real candidates for functional roles in living organisms. The broad claim that life broadly harnesses quantum effects in ways that explain consciousness or perception is not established. And then there is the problem that exceeds all of these in scale. In 1998, 3 independent teams, led by Saul Perlmutter at Lawrence Berkeley National Laboratory, Brian Schmidt at Australian National University, and Adam Rees at Johns Hopkins, measured the expansion rate of the universe using distant supernova and found something they had not been looking for. The expansion is accelerating.
Something is pushing space apart at an increasing rate. The something has been named dark energy.
Its best description is Einstein's cosmological constant, a non-zero energy density of empty space, uniform everywhere, constant in time. The measured value is extraordinarily small, approximately 1029 grams per cubic centimeter. Real. Confirmed. Awarded the Nobel Prize in 2011. The quantum field theoretic prediction of the vacuum's energy density is approximately 1094 grams per cubic centimeter. The discrepancy is around 120 orders of magnitude. This is the largest quantitative disagreement between theory and observation in the history of physics. There is no agreed solution. Supersymmetry would cancel much of the discrepancy if it existed. It has not been observed at the energies reached by the Large Hadron Collider. The anthropic argument says the constant has the value it has, because a larger value would have prevented the formation of structure. Galaxies, stars, planets, observers. This is not a physical explanation. It is the notation of a failure. The vacuum hums. The universe is not crushed by the weight of the hum. Nobody knows why. This is not a calculation error. It is not an oversight awaiting a correction. It is the most precisely stated unsolved problem in theoretical physics. A confrontation between the two best confirmed frameworks in science, quantum field theory, and general relativity, which agree on almost nothing about the energy of the vacuum. The reconciliation of these two frameworks is the central project of fundamental physics. It has been attempted for decades. Nothing has worked. So here, precisely, is where the physics stands. The confirmed foundation is solid. At the deepest level, matter is field excitation. Process, not substance. Energy is bound to frequency. The vacuum has structure. The atom holds because its electron is a standing wave. The most precise relativistic equation physics has written for the electron carries, in its algebra, an irreducible trembling. All of this is confirmed, tested, reproducible, not in doubt. What is not confirmed is what any of it means. What physical process constitutes a measurement? Why one outcome appears? What the wave function is a description of when no measurement is being made? Why the vacuum's calculated energy density does not determine the universe's expansion? These are not puzzles at the edge of the map. They are gaps at the center, and the structural features the confirmed picture exposes are specific. Reality at the foundation is not made of things. It is made of processes. Measurement does not passively detect pre-existing properties. It participates in their establishment. The separability of parts, the assumption that any object has properties independent of its relations to other objects, has been demonstrated by experiment to be false at quantum scales. These are not interpretations. They are what the confirmed formalism shows. There's something worth sitting with in the quiet. The picture that has emerged from a century of the most careful measurement in human history describes a reality in which the solid thing is always the surface, the depth is always process, and the act of looking is never fully separate from what is seen. The physics does not explain what this means. It has confirmed that it is the case. There are older investigations conducted by different methods in different centuries, in languages the physics was not trying to use, that arrived at a structurally similar edge. Not because they anticipated the physics, not because the physics validates them, but because the same shape of reality, approached from a different direction, can produce a recognizably similar outline. The languages are different. The methods could not be more different. What remains, when both are held intact and neither is collapsed into the other, is worth attending to carefully. That is where the account turns next.
The traditions in question arrived at their conclusions by the opposite road from the physics.
The physics moved outward and inward simultaneously. Outward toward the very large through telescopes and accelerators, inward toward the very small through instruments of increasing precision, until both directions converged on the same strange picture. The traditions moved inward only, into the structure of attention itself, into the question of what is doing the experiencing. They had no apparatus. They had sustained inquiry, refined across centuries, transmitted from teacher to student in conditions that required the full participation of the learner. This is not the same kind of knowing. The method is different. The domain is different. The claim is different. What the physics claims to show is how matter behaves at the deepest level it has reached. What the contemplative traditions claim to show is how awareness is at the deepest level they have reached. These are not the same subject. A structural resemblance between their findings does not make them the same investigation, and yet the resemblance is structural, not metaphorical, not rhetorical, not inspirational. The physics shows a reality in which nothing has self-standing, independent existence, in which properties are relational rather than intrinsic, in which the act of measurement participates in what is measured, in which no separable, substance-bearing object exists at the foundational level. The traditions describe, through methods the physics does not use, in a domain the physics does not reach, a reality in which nothing can be permanently possessed, in which the self that tries to possess dissolves under sustained examination, in which the project of holding a stable state runs into the same wall from the inside that the physics runs into from the outside. The two roads are not the same. The structure at their end is the same. This distinction is the ground everything in this section stands on, and it will not be abandoned. 2,000 years ago, a monk in South India did something no one before him had done quite so thoroughly. He did not teach a doctrine. He dismantled the possibility of any doctrine. His name was Nagarjuna, and the text he composed, the fundamental verses on the middle way, the Mula Madhyamaka Karika, is the most rigorous philosophical document in the Buddhist tradition, and among the most rigorous in the history of philosophy. The aim was precise, to articulate the Buddha's teaching of the middle way, not as a compromise between extremes, but as the demolition of every extreme position about reality. Nagarjuna took the four possible positions about anything: that it exists inherently, that it does not, that it both does and does not, that it neither does nor does not. These are the four corners, the Katuskoti, the complete set of positions available to a mind seeking to fix reality in place. He showed methodically that each leads to contradiction. No position survives. What is left is not nothing, but it cannot be stated as a positive doctrine either. What remains is emptiness, shunyata, the recognition that nothing possesses svabhava, an intrinsic nature independent of everything else. Things arise only in dependence on other things in a web of mutual conditioning. This is dependent origination, pratyasamutpada. Nothing has being apart from its dependent relations. The popular version says, everything is empty, meaning everything is illusory, meaning nothing is real. Nagarjuna said none of this. He did not say the table is unreal. He said the table has no reality that is not constituted through its relations. To the wood, to the carpenter, to the floor, to the concept table, to the hand that needs a surface. Remove the relations, and there is no residue called tableness that remains. The table is not nothing. The table is not self-standing. But here is the teaching almost no popular account transmits. Shunyata is itself shunya.
Emptiness is empty.
This is the content of the 13th chapter of the Mula Madhyamaka Karika, and it is the most important chapter in the text. If emptiness were a real thing, a metaphysical substrate, a true foundation, the real behind appearances, then the doctrine of emptiness would be just another positive claim about what is ultimately real. And Nagarjuna's own analysis would demolish it, as it demolishes every other positive claim. The teaching self-refutes its own doctrinal status. This is not an accident or a paradox to be resolved. It is the precision of the teaching. The view is not a view to hold. It is the activity of releasing the grip on every view, including the grip on emptiness as a view. This is what the lineage transmits that the texts only point toward. Emptiness is not a fact to be known, but a way of holding every fact, lightly, without consolidating around it, without building a permanent position from it. The practitioner who has grasped the doctrine of emptiness and is satisfied with having grasped it has made a new kind of grasping. The tradition calls this the extreme of nihilism, the mistake of using emptiness as a ground to stand on, which is precisely what the analysis showed cannot be done. What does this feel like from the inside? A practitioner trained in this tradition sits with a question. What is this thought? Where is it? What is it made of? The question is not answered philosophically. It is investigated through sustained attention. What is found is not nothing. What is found is the absence of the solid object assumed to be there. The structural parallel to what physics found is not casual. In quantum field theory, the electron is an excitation of the electron field. It has no self-standing existence apart from the field and its relations to other fields. Its properties are not intrinsic, but are defined through coupling, interaction, measurement. Carlo Rovelli's relational interpretation makes this explicit. There is no observer-independent quantum state. Facts are relational. Nothing has absolute context-independent properties. And at the level of the vacuum, field excitations arise, persist only through their interactions, and dissolve. No self-standing grain at the bottom. The languages are completely different. The methods are entirely different. Nagarjuna was not doing physics, and the physicists were not doing philosophy in Nagarjuna's mode. But the architecture maps onto each other with a precision worth attending to. The tradition uses this image. A rainbow is vivid, colored, located. Look for where it begins and ends, what it is made of, what persists when you move, and you find only the angle of light and the drops and the eye that receives them. The rainbow is not an illusion. It is not nothing. But nowhere in it can you find the self-standing object you took it to be. The physics of the rainbow is completely understood. The rainbow is still completely there. Both are true simultaneously. This is the shape of the teaching. From the Madhyamaka's philosophical demolition, a different school in the same Tibetan Buddhist inheritance arrives at the same edge by a different route, not through argument, through transmission, not through the dismantling of intellectual positions, but through direct pointing at what cannot be positioned. Longchenpa, the 14th century Tibetan master, whose treasury of the Dharmadhatu remains the most complete systematization of the Dzogchen tradition, distinguished between two things that are frequently confused even by practitioners. He called them ordinary mind and pure awareness. In Tibetan, Sems and Rigpa. Sems is ordinary mind, the mind that thinks, judges, remembers, fears, hopes, and generates experience. It produces the full range of states: agitation, calm, confusion, clarity, fear, bliss. Sems is always doing something. It is always in a state.
The states vary. Some are painful and some are beautiful. But they are all SEMs. Rigpa is not a state.
This is the teaching. Rigpa is the nature of mind itself, the open, self-knowing awareness that underlies all mental activity without being produced by it or identified with any of it. The Dzogchen lineages describe it as without edge or center, timelessly present, not born, not fabricated, not found by searching, and not lost by forgetting. The practices of Dzogchen, including the direct introduction transmitted orally by a qualified teacher and the practice of sustained openness in stillness, are designed to reveal what is already the case, not to produce something new. And here is precisely where the popular version of this teaching goes wrong. It is widely said, in the spiritual conversation that borrows Dzogchen language without its precision, that the goal of practice is to reach a high state of clarity or bliss or openness and maintain it throughout the day, to stay in the good experience, to keep the light on. The practice is framed as achieving a state, and the measure of progress is how long the state lasts. The Dzogchen lineage teaches the opposite. The passing experiences, the bliss, the clarity, the vivid luminosity that sometimes arises, are called niyams, meditative experiences, and the oral transmission from every qualified lineage holder in this tradition is explicit and consistent. Niyams are not rigpa. They are sems, refined, beautiful, even extraordinary states of ordinary mind. And the instruction transmitted for niyams is this: do not follow them, do not suppress them, and above all, do not grasp at them or try to sustain them, because the grasping is the obstacle. To try to stay in a good state all day is not the fulfillment of Dzogchen. It is the specific error Dzogchen has always named: the confusion of sems for rigpa, the confusion of an experience for the nature of mind. Rigpa cannot be held because it was never produced. It is the ground of every experience, not an experience itself. You have had a clear morning, a quality of ease, of openness, the sense that everything is settled, and you reached for it to keep it, and it was already different. The reaching itself changed it. This is not a failure of practice. This is what states are. They arise and dissolve. The state slipped not because your technique was wrong, but because a state is something that comes and goes, and the wanting to keep it is always already the wanting that takes it beyond reach. What Longchenpa's transmission points to is the recognition that the openness you were trying to hold was never a thing that could be held, and that the recognition of this, not as a disappointment, but as a direct seeing of what is the case, is itself the relaxation the practice was pointing toward, not a new, better state, the release of the effort to grasp any state. The structural parallel is specific. In quantum mechanics, the quantum Zeno effect describes what happens when a quantum system is continuously measured to check whether it remains in a particular state. The continuous measurement actually prevents the system from evolving. The watching is what holds it in place, not by force of awareness, but by the physical act of entanglement with the measuring apparatus. The more you check, the more the state is frozen into what you are checking for. And the natural process, the evolution the state would undergo if left alone, is suspended for as long as the checking continues. This is not a proof of the Dzogchen teaching, and Dzogchen is not a description of the quantum Zeno effect. They are addressing different subjects by different methods in entirely different domains. But the architecture is the same shape. The grasping at a state is what prevents the natural movement that the state, left to itself, would undergo. The image the Dzogchen tradition uses, the sky and the clouds. The sky is not the clouds. is not colored by the clouds, is not disturbed by them, and is not produced by their absence. Clouds arise in the sky, move through it, and dissolve without leaving a mark. Rigpa is like the sky. The Nayams, the beautiful passing states, are like the clouds. You cannot make the sky by removing clouds. You cannot hold the sky by keeping clouds away. The sky is always already what it is. Every session of practice begins with what was never produced and ends with what was never lost. The practice is the recognition of this, not the creation of it. The recognition that the ground cannot be accumulated, that the adding of effort moves in the wrong direction, arrives also in the oldest continuous philosophical tradition in East Asia, by yet another route. In the 3rd century of the Common Era, a young Chinese scholar named Wang Bi wrote a commentary on the Tao Te Ching that would become one of the most influential interpretive documents in the Chinese literary tradition. He died at 23. He left behind an interpretation of the most famous 81 chapters in Chinese literature that has shaped how that text has been read for 17 centuries. The Tao Te Ching, attributed by tradition to Laozi, though no historical Laozi is recoverable and the text as we have it was probably composed across several centuries, poses its central puzzle in its first line. The Tao that can be spoken is not the eternal Tao. What follows is 81 chapters circling what cannot be named, the source of all things, the ground of being and non-being, the principle that precedes and underlies every determinate form without itself being any form. Wang Bi read the Tao through Wu, non-being, or more precisely, the absence of determinate form, the unconditioned from which all conditioned things arise. The Tao is not nothing in the sense of vacancy. It is nothing in the sense of not yet determined, prior to the distinctions that make things what they are. Everything arises from this ground. The sage is the one who has found a way of acting, effortless action, Wu Wei, that arises from this undifferentiated ground, rather than from the calculating, grasping activity of a self trying to achieve outcomes. Wu Wei is not laziness, not passivity. It is the action that does not force, that arises when the actor has become transparent to what the situation requires, when nothing personal is added to the response. The Tao Te Ching describes water. It flows to the lowest places, benefits all things, and does not contend. This is not water as metaphor only. It is water as a demonstration. The thing that nourishes and persists is the thing that does not fight the shape of its container. You have known the difference between a conversation that flows without effort and one you are pushing. The effortful version is not better for the effort. The effort was always already resistance. And here is the content that most popular accounts of the Tao Te Ching do not transmit. Wang Bi's reading is not the only classical reading, and the alternative produces a fundamentally different Tao. The Heshang commentary, attributed by tradition to a Han Dynasty hermit, probably composed in the 2nd or 3rd century CE, reads the same 81 chapters as a manual for physiological cultivation. The Tao in this reading is a principle that can be accumulated through breathing practices, dietary discipline, the conservation of vital essence, the internal alchemy tradition, the cultivation of qi, the Taoist health lineages. These descend from the Heshang Gong reading. In this version, you can raise your internal charge. You can work toward the Tao through technique and accumulation. Wang Bi and Heshang Gong are not reading the same text. They are reading two different documents that happen to share the same 81 chapters. Both readings are present in the classical tradition. They have been in tension for 2,000 years.
Any account that treats them as a single, consistent voice is already wrong.
And any account that borrows the word Tao to describe the accumulation of a spiritually charged state has chosen, without knowing it, the side of the debate that Wang Bi spent his short life arguing against. Wang Bi's reading points away from cultivation and toward effortlessness. The Chinese word ziran, self-so, spontaneity, the arising of things in accordance with their own nature, names what the Tao produces, not controlled outcomes, not accumulated power, but the self-arising of forms when nothing is forcing them to be otherwise. The structural parallel is specific. The quantum vacuum produces field excitation spontaneously, without external compulsion, according to the vacuum's own quantum nature. There is no agent accumulating the vacuum's activity. The excitation is what the field does when left to be what it is. This is Ziran in the structure of matter, the self-so arising of forms from an undifferentiated ground that cannot be captured or increased. The Tao is not the quantum vacuum. Wang Bi was not describing a physical substrate. What rhymes is the architecture, an undifferentiated ground from which all determinate forms arise, which cannot be possessed or accumulated, and which is approached not by adding anything, but by subtracting the interference of the grasping mind. The classic image: a room is useful not because of its walls, but because of the space the walls contain. The emptiness inside makes the room a room. It is the nothing within the something that does the work. In the century after the Tao Te Ching was receiving its most systematic commentary, a scholar from Al-Andalus was completing in Damascus the largest mystical text in the Arabic language. His name was Ibn Arab, Muhi al-Din Ibn Arab Bois, and his two principal works, the Meccan Openings, the Al-Futuhat al-Makkaya, and the shorter Bezels of Wisdom, the Fusus al-Hikam, became the central documents of speculative Sufi philosophy, generating hundreds of commentaries in the centuries after his death in 1240. The central doctrine associated with his name, formulated precisely by his student Al-Qanawa, is the unity of being, Wahdat al-Wujud. There's only one existence, and that existence is divine. Created things do not possess existence in themselves. They are the self-disclosure, the tajal, of the one being through its own names and attributes. The universe is the theophany, the revelation in which the divine nature makes itself known through the multiplicity of forms. Within the Sufi tradition that Ibn Arab inherited and systematized, there is a precise psychology of spiritual experience. Two terms carry most of the weight: the passing state and the earned station. The passing state, hal, is a grace state that descends upon the practitioner without being summoned and without being held. Al-Junayd of Baghdad, who established the foundational framework of classical Sufism in the 9th century, and Al-Qushayr, whose 11th century epistle became the standard textbook of Sufi practice, were both explicit. The hal cannot be commanded. It cannot be held. Its departure is not a failure. It is characterized by the very quality of transience. It is that which visits and cannot be installed. The earned station, maqam, is entirely different. It is the ground permanently occupied through sustained practice and discipline. Stations of repentance, patience, gratitude, renunciation, and trust are not passing experiences, but structural changes in the practitioner, built slowly, stable across varying conditions. The maqam persists not because the practitioner holds it, but because the practitioner has become it. There is something the body recognizes in the hal, a quality that sometimes arrives in the early morning before thinking has begun, or in the aftermath of something beautiful, or without apparent cause. It is already different the moment you try to name it or retain it. This is not the poverty of your practice. This is what a hal is. The Sufi tradition is clear and specific. The practitioner who designs spiritual life around producing the hal and maintaining it has confused the visitation for the destination. The maqamat are built not by holding hal, but by moving through them and working with what remains. And here is the more hidden content. Beneath the hal, maqam distinction, Ibn Arab makes an ontological claim that was controversial in his time and has remained so for 8 centuries. He describes the barzakh, a word the Quran uses for the boundary between the realm of the dead and the world of the living, as an ontological intermediate, the imaginal isthmus, the Hadrat al-Khayal, a genuine ontological category, neither purely spiritual nor purely material, not the imagination as a psychological faculty, but a real domain with its own beings and its own laws, accessible to the faculties trained by sustained contemplative practice. This was the claim the Orthodox tradition found most difficult to accommodate, not the unity of being alone. That was controversial enough. The claim of a third ontological category between pure spirit and physical matter, with real inhabitants and real geography, was resisted for centuries by a tradition that preferred to keep the categories clean. Ibn Arab's defenders argued, then and since, that the barzakh is the most precise account of what the prophetic and mystic experience actually is, neither purely mental nor physically verifiable in the ordinary sense, but real in a way the tradition has always affirmed while rarely knowing how to describe. The structural parallel here is honestly limited, and the limit should be stated. Physics has no equivalent of the barzakh. There is no quantum mechanical category that maps onto the imaginal isthmus. What the physics and the Sufi tradition share at the structural level is more modest, the recognition that the passing state cannot be held, and that the stable configuration, the ground state, is not achieved by clinging to the transient, but by moving through it. A quantum field returns to its ground state, not by sustaining an excitation, but by releasing it. The practitioner moves toward the maqam, not by grasping the hal, but by allowing it to pass and working with what the passing reveals. The physics did not produce this teaching. The Sufi tradition did not anticipate the physics. The structure rhymes. The disciplines are distinct. In the 14th century, a century of extraordinary contemplative productivity across both Eastern Christianity and the Tibetan tradition, a controversy was fracturing the Eastern Church that would ultimately produce the most precise theological analysis of spiritual experience in the Christian world. At its center was Gregory Palamas, the defender of the hesychast practice of inner prayer, who became Archbishop of Thessaloniki, and whose triads in defense of the holy hesychasts formulated a doctrine that the Eastern Orthodox Church accepted as definitive. The controversy was simple in its terms and deep in its implications. The hesychasts, monks who practiced the prayer of the heart, synchronizing attention with breath, and a single repeated invocation in conditions of sustained interior stillness, claimed to perceive, in advanced states of practice, the divine light directly. Not a vision produced by the mind, not a symbol or metaphor, a real, uncreated illumination, the same light perceived at the Transfiguration. The critics, led by the scholastic theologian Barlaam of Calabria, held that this was impossible. God's essence is entirely unknowable. No creature can know God directly, and therefore the experienced light must be created, a product of the mind or of some intermediate being. Palamas's resolution, which became the orthodox doctrine of theosis, proposed a distinction that is both precise and radical. God's essence and God's activities are really distinct, not merely conceptually distinct. The essence, what God is entirely unknowable and unapproachable. The divine activities, the energeia I, the uncreated operations through which God is genuinely present in creation, are truly God, but not the divine essence, and are truly knowable through participation. Theosis, the deification of the human person, is real participation in the uncreated divine energies, not a metaphor, not a psychological event, not a created grace. The distinction is real. The operative content of this teaching is transmitted through the Philokalia, the anthology of Hesychast's texts compiled in the 18th century. What it transmits is not primarily a technique for producing spiritual states. It is a discipline of attention, watchfulness, nepsis, the sustained noticing of thoughts before they consolidate into action or identification. The contemplative practice in this lineage is aimed not at producing something new, but at becoming transparent to what is already present, a presence the practitioner does not generate, but learns to receive. And here is the word that the popular spiritual conversation requires. The word energy, the one the vibration and frequency discussion reaches for, arrives through a long degradation. The Greek energeia. Aristotle used it to mean the actuality of a thing, the being at work that makes it what it is. The Christian tradition, including Palamas, used it to mean uncreated divine activity, the real presence of God operating in creation. The early modern natural philosophers condensed it into a technical term for the measured capacity of a physical system to perform work. And the New Age movement extracted it from both contexts and turned it into a generic spiritual substance to be raised, accumulated, or balanced. This path is real. The etymology does not prove anything about the physics or the theology. What it shows is how a term with precise technical content in two separate disciplines, Palamite theology and physics, gets hollowed out when it passes through 100 years of popular simplification. The structural parallel here is faint, and it should be named as faint. Both the Hesychast tradition and the physics make a distinction between an inaccessible ground and an accessible activity. The divine essence in Palamas is unknowable. The divine energies are knowable through participation. The absolute wave function is unobservable between measurements. The measurement outcomes are accessible through interaction. This is an architectural rhyme, not a proof. The two subjects are different. Neither confirms the other. What they share is the picture of a depth that is real and not directly available, and an activity that is both real and accessible without exhausting the depth behind it. The practice of inner stillness, hesychia, does not produce the light. It creates the conditions in which what was always present can be received. This is not accumulation. It is the absence of interference. 4 traditions and a 5th, different centuries, different continents, methods that have almost nothing in common. Nagarjuna's dialectic, Longchenpa's direct pointing, Wangbi's reading of an ancient text through the lens of ontological non-being, Ibn Arabi's decades of systematic speculative mysticism, the Hesychast practice of breath and sustained attention. None of them were trying to reach each other. None of them were trying to anticipate a physics that would not exist for centuries or millennia after their deaths. And yet, the picture they arrive at has a specific shape. Nothing has self-standing existence. The ground cannot be possessed. The solid thing is always the surface. The grasping of a stable state is the obstacle, not the fulfillment.
The approach to the depth requires not the accumulation of something new, but the release of what has been forced. This convergence is not casual.
5 independent investigations by methods that do not resemble each other, arriving at the same structural picture. The convergence is the data. It does not prove that any one tradition is right, or that the physics confirms the traditions, but it does suggest that the structural picture, reality in which nothing is self-standing, in which the grasping of the ground is what obscures the ground, is not the invention of any single school or method. It has the character of something that is found repeatedly by anyone who looks carefully enough, from any direction. This is not coincidence, but it is not proof. The traditions do not confirm the physics. The physics does not validate the traditions. They are different investigations, in different domains, making different kinds of claims. The structural resemblance is the most that can honestly be said, and anyone who reaches past that, in either direction, science towards spirituality or spirituality towards science, is claiming more than the evidence supports. What the resemblance shows is something smaller and stranger than a unified theory. It shows that the question the physics has arrived at: what is the nature of the ground that cannot be possessed? The process that cannot be held as an object? The reality in which nothing is self-standing? Is not a question the physics has arrived at for the first time. It has been arrived at before, many times, by roads that leave no instruments behind. The question is still open. In the physics and in the traditions, the question remains without a final answer. What the physics and the tradition share is the open question, and the recognition, hard-won in both cases, that the question cannot be answered by grasping at it, that the attempt to hold the answer is precisely the gesture that prevents the answer from being found. So what does all of this mean? Not for the physics. The physics has its own account of what it means, a precise chain of evidence and mathematics running from a reluctant German physicist in 1900 to a force measured between 2 metal plates in 1997 to an electron's trembling simulated in a single trapped ion in 2010. The physics knows what it means within its domain. The question underneath that domain is different. What does any of it mean for the thing that is asking? Both roads arrived at the same edge, the road of instruments and the road of silence, the road of measurement and the road of sustained inward attention. Neither has crossed the edge they found. Both confirmed, through methods as different as any 2 methods can be, that the solid thing is always the surface, that the depth is always process, that the attempt to hold the ground is what produces the slipping. This is not a conclusion. It is a standing. What standing here honestly requires is neither the physicist's posture alone. Here is the evidence. Here is what it confirms. Here is what remains open. Nor the contemplative's posture alone. Here is the practice. Here is the path. Here is what the realization asks of you. It requires something that neither discipline fully provides: the capacity to remain in front of an open question without solving it or abandoning it. The capacity to say both, "This is confirmed," and "This remains unknown," in the same breath, and to mean both equally. Both roads acknowledged, when they arrived, that the arriving was inconclusive. The physics cannot say what the wave function is between measurements. The traditions cannot say what Rigpa is to the one who has not been directly shown. Both can point. Both know that the pointing is not the thing it points at. The ground is open. What follows is an attempt to stand on that ground precisely, naming what is confirmed, what is suggested,
what remains genuinely unknown, and what the honest voice cannot claim. What is established is this: energy is proportional to frequency, mediated by Planck's constant.
This is confirmed in every spectroscopic measurement, every photoelectric device, every laser and LED and photovoltaic cell operating anywhere on Earth. It is not an interpretation. It is a law, and it is the foundation on which everything that follows is built. Matter has wave character. De Broglie's relation has been confirmed not just for electrons, but for neutrons, atoms, and large molecules, including by Anton Zeilinger's group in Vienna in 1999, Buckminster-Fullerene, a cage of 60 carbon atoms diffracted through a grating, producing interference fringes on a screen, behaving as a wave. The wave character of matter is not a metaphor. It has been photographed. The fundamental ontological category is field, not particle. The Standard Model's quantum fields describe all known fundamental interactions to extraordinary precision. The electron is an excitation of a field. The photon is an excitation of a field. What we call particles are quantized modes of underlying fields that fill all of space. This is not speculation. It is the structure required to make the most precise predictions in the history of science work. The vacuum has measurable structure. The Casimir force is real, confirmed, and has been used in the design of micromechanical systems. The nothing between things presses on things. This sentence is not metaphor. Decoherence explains, without additional physical postulate, why the macroscopic world appears classical. The quantum superpositions of large systems dissolve into their environment so quickly that they are, for any practical physical process, inaccessible. This is established. These are the things physics has confirmed. Stated flatly, they have a cumulative weight. They describe a reality whose most fundamental layer is fields everywhere, always active, with no static grain at the bottom, producing through their excitations every object that has ever been touched or seen. What seemed solid is pattern. What seemed empty hums. What seems still is the quantum harmonic oscillator at its ground state, moving as minimally as the uncertainty principle permits. There is something worth sitting with in this before the summary moves on. You have never touched anything solid. You have never been in empty space. Every object your hand has ever met was a field meeting, a field. Patterns refusing to pass through each other, producing the sensation of contact. Every quiet room you have ever entered was full of vacuum fluctuations, full of the zero-point motion of every field that permeates the space, full of the structure that the Casimir force confirmed you can measure if you bring two plates close enough together. The world that seems to be made of objects in spaces is actually a seamless activity of fields, in whose excitations the objects briefly persist. And there is one more thing established, not by physics, but as a historical fact about the traditions. 5 independent investigations using methods that have nothing in common with each other or with physics, conducted across more than 2,000 years on multiple continents in languages that never met, arrived at structurally similar pictures of reality. No self-standing existence, no possessible ground. The stability you seek cannot be held because it was never a thing. The depth is process. The traditions do not agree on everything. Their differences are as significant as their similarities, and flattening them into a single voice is its own kind of error. But on this specific structural question, on the question of whether the solid is the surface and the depth is process, the convergence across the traditions is a fact. What it means about reality is a different question. The fact of the convergence is established. What is suggested, not confirmed,
not established, but pointed toward by the evidence, is something more than the sum of these parts.
The structural picture that physics found at the quantum scale. Nothing has intrinsic properties independent of its relations. Measurement participates in what is measured. No observer stands entirely outside what is observed. May not be merely a quantum scale fact. The physics does not yet know whether process ontology is a fundamental feature of reality at all scales, or an artifact of the quantum regime that disappears into classical mechanics at large scales. The decoherence explanation of the apparent classicality of macroscopic objects says, yes, the quantum character is there at all scales, but it becomes practically inaccessible at human scales and above because the entanglement with the environment is so total and so fast. This suggests, without proving, that the classical world of definite objects is a valid engineering approximation operating on top of a quantum substrate that never stops being what it is. The solid table is not a lie. It is a pattern in fields that are themselves excitations in a vacuum that never stops trembling. What is also suggested is that the convergence between the traditions and the physics is not pure coincidence. 5 independent investigations, by different methods, producing structurally similar pictures, is evidence of something. Not proof of a shared spiritual reality. Not proof that all traditions say the same thing. They do not, and the differences are as significant as the similarities. But evidence that the structural question, what is the nature of the thing that cannot be grasped, the ground that cannot be possessed, is not an arbitrary or culturally contingent question. It is a question that repeated independent investigation tends to arrive at. That is worth noting, carefully, with both hands. What is also suggested, at the very edge of the established, is that quantum effects may extend further into biology than was thought possible 30 years ago. The radical pair mechanism in cryptochrome remains the best candidate for a genuine quantum biological effect, and the behavioral evidence points in a consistent direction. If it is confirmed by direct measurement, which has not yet been achieved, it will mean that quantum coherence operates in living tissue at body temperature, doing real navigational work. This is suggested, not established. And what is suggested, this is the most difficult to state without overclaiming, is that the relationship between the observer and the observed, left genuinely unresolved by the physics, is not merely a technical problem awaiting a technical solution. The measurement problem has been open for 90 years. Every generation of physicists has either deferred it or declared it solved by some interpretation that the next generation has found wanting. The suggestion of this pattern is that the question is genuinely deep, that it is pointing at something about the nature of observation that the physics' current framework cannot contain. What remains genuinely unknown is the larger territory, and it should be named precisely without softening. The measurement problem is open. What physical process constitutes a measurement? Why, in a deterministic and linear theory, a single definite outcome appears? Whether the wave function is a real physical object, or a summary of an agent's beliefs, or something else entirely, the interpretations are multiple. No experiment distinguishes between them. No interpretation commands consensus after 70 years of serious professional debate. This is not a detail waiting for a better instrument. It is the foundational question about what the theory is a description of. It is unsolved. Not unsolved because the question has not been asked. Unsolved at the foundation. The cosmological constant problem is open. The quantum field calculation of the vacuum's energy density disagrees with the measured value by approximately 120 orders of magnitude.
No agreed solution.
No experimental hint of what would close it. The most successful physical framework in history fails, at this question, more spectacularly than any other theory has ever failed at any other question. This is unsolved. Whether decoherence resolves the measurement problem or only redescribes it in more sophisticated language is genuinely debated among the physicists who have looked most carefully. Decoherence explains why we see one outcome rather than an observable superposition. It does not explain why the universe's quantum state, which still contains all outcomes in superposition after decoherence, should be treated as having selected one. The global state is still a superposition. What Zurek's theory shows is that the different branches are effectively non-interacting. Whether effective non-interaction is the same as actual single outcome is the question. It is open whether the structural convergence between the contemplative traditions and the physics reflects a shared underlying reality, or reflects the structure of the kinds of questions the human mind generates when investigating fundamental structure, is genuinely unknown. Both possibilities are live. A materialist interpretation says, the traditions were asking questions structured in a way that produces certain types of answers, and quantum physics arrived at similarly structured answers, because any deep investigation of fundamental structure tends to produce certain recurring patterns, regardless of method. This is a respectable position. It cannot be ruled out. Whether the contemplative realizations described in the traditions are accessing something about reality that the physics does not reach, whether the inner path, followed far enough, arrives at a different kind of knowing than the outer path, is unknown and may be unknowable by any current method. The traditions claim that the realization is a transformation of the one who realizes it, not a set of propositions to be assessed from outside. This claim cannot be tested by any external instrument. It can only be evaluated by the one who enters the practice and stays long enough to see. Whether what is found there is what the traditions describe, or whether it is a refined and culturally shaped psychological state with certain common features, is genuinely open. The relationship between consciousness and physics remains unresolved at a deeper level than any popular account acknowledges. Not because consciousness might collapse the wave function. That claim has no experimental support and rests on a confusion about what the word observer means in the formalism. But because the question of what consciousness is, how it arises from or relates to, the physical processes that the physics describes, has not been touched by the physics at all. The physics describes the behavior of matter. Whether the experience of being a creature made of matter, the bare fact of there being something it is like to be here, is explicable by the physics, or constitutes a further fact the physics does not address, is one of the deepest and most genuinely open questions in all of human inquiry. The hard problem of consciousness has been discussed by serious philosophers and scientists for decades. No one has solved it. No one has even agreed on what a solution would look like. We do not know, not as a rhetorical flourish, as the honest accounting of where the investigation has arrived. The foundation is solid. The interpretation is open. The depth is real. The depth is unresolved. And here is where the legitimate skepticism must be stated, because it is earned. A careful materialist looking at everything that has been said here could reasonably object. You have described a set of interesting structural similarities between very different investigations, and invited the listener to feel the weight of the convergence. But structural similarity between different investigations is exactly what cognitive bias produces. The human mind is extremely good at finding patterns. It was selected for that ability over millions of years. Finding patterns in noise is what it does best and least critically. The fact that quantum field theory and Madhyamaka Buddhism both describe a reality without self-standing objects tells you something about the structure of questions humans ask about fundamental reality. It may not tell you anything about fundamental reality itself. The traditions were developed by human beings in specific cultural contexts to address specific human concerns, primarily suffering, liberation, the conduct of a good life. Quantum physics was developed to describe the behavior of subatomic systems. That their metaphysical frameworks share structural features may simply indicate that human minds, investigating any deep question, tend to generate certain types of answers. Pattern recognition is a bias before it is a discovery. This is a fair objection. It cannot be dismissed with the counter-argument that the convergence is too precise to be coincidence, because that assessment requires knowing what the base rate of such coincidences is, and no one has established that. The honest position acknowledges the objection and does not have a definitive answer to it. A rigorous contemplative, looking at the same material from the other direction, could reasonably object. The structural parallel you have described is conceptually interesting and practically worthless. The understanding that Madhyamaka and quantum field theory share an architectural similarity gives the listener nothing that matters for the actual project the traditions were aimed at. Nagarjuna's analysis was not aimed at producing an interesting metaphysical position. It was aimed at producing a specific kind of transformation in the one who undergoes it, a transformation of the habitual tendencies that produce suffering, that require years of practice, guidance, and the willingness to apply the analysis directly to one's own patterns of grasping. Reading about the structural parallel between QFT and shunyata leaves the listener in exactly the position they were in before, perhaps more informed, perhaps impressed, experientially unchanged. The map and the territory are not the same. The traditions were always pointing at the territory. This is also a fair objection. It is one the traditions themselves would make. The description of the recognition is not the recognition. The finger pointing at the moon is not the moon. Both objections are honest. Both deserve their full weight. The voice here does not collapse into either materialist dismissal or contemplative prescription. What remains, after both objections are heard, is the open ground. The question is real. The convergence is real. The territory is not closed. And the distance between the map and what the map points at is the distance every investigation ultimately faces. You have stood in front of this question too. Not in a laboratory, not in a meditation retreat, in the middle of an ordinary life, in an ordinary evening. You have felt the shape of it. You have had a morning that was clear in a way that could not be accounted for by anything that happened the night before. A quality of openness, a sense that things were, for a moment, in their right proportion. And you have noticed, somewhere in the middle of it, that the noticing changed it, that the reaching for it was the beginning of its going. That has always been the structure of the experience. The reaching changes what it reaches for. You have stood in a quiet room at night and felt the room not be empty, not felt anything specific in it, just felt the not emptiness, the way you feel a presence before you see one. The physics has a name for that now. The vacuum has structure. The nothing between things does something. The feeling and the physics are not the same account, but they are pointing in the same direction. You have, at some moment, understood something, not from reading or argument, but from a direct recognition, a clarity that appeared without being summoned and dissolved when you tried to hold it. You may have spent years trying to find that recognition again, trying to reproduce the conditions that produced it, trying to install it as a permanent feature of your experience. The traditions all have names for what you were looking for. They have names for why the looking was the obstacle. The physics does not reach this question directly, but the architecture of what both the physics and the traditions found. Nothing can be held. The grasping is what obscures. The ground is what remains when the forcing stops, runs all the way through. These experiences are not proof of anything. They are not evidence for any particular metaphysics. They are data of a kind that neither the physics nor the traditions can fully account for, and both acknowledge as real. The physics says, the observer cannot be fully separated from the measurement. The traditions say, the one who looks is part of what is looked at. These are not the same statement, but they are facing the same direction. The question you began with, how to stay in the good state, how to hold the clear morning in place, how to find a steady ground and live in it, is not a foolish question. It is, in fact, the question. The same question the traditions spent millennia refining. The same question the physics has been probing from outside for a century. The honest answer from both directions is the same. The stable ground is not a state that can be held. The reaching for it is what obscures it. What is there when the reaching stops is not nothing. What is there has no name that anyone has agreed on. The traditions have pointed at it in dozens of languages across thousands of years. The physics has described its outer behavior with extraordinary precision. Neither has named it. Both are still looking. And then the inquiry settles, and the night is what it is. The physics arrived, over a century, at a picture of matter as excitation all the way down. No solid grain, no resting substrate, only fields in their ground states, producing through their modes every pattern that has ever been called a thing. The traditions arrived over millennia at a picture of experience in which no state is possessible, no ground is fixable, no self-standing thing survives close examination. Both pictures are specific and precise. Both are still open. Both are still asking. What the two pictures share at their deepest level is not a conclusion, but a posture, an honest willingness to let the inquiry arrive at what it actually finds, rather than at what was hoped for at the start. The physics hoped to find, at the bottom of matter, something solid, something deterministic, something fully knowable. It found instead the field, the excitation, the irreducible uncertainty, the vacuum that hums. The traditions hoped, in the beginning of practice, to find a stable high state to inhabit, a clear morning that would not thin. They found instead that the reaching was the obstacle, and the release of the reaching was the opening. In both cases, the finding was not what was sought. In both cases, the finding was more. The body has weight. The mattress holds it. The walls hold the room, and the floor holds the walls. And somewhere beneath the floor, the earth holds everything, patient and unmoving, the way ground has always seemed to hold. The world presents itself as solid. It has always presented itself this way. And somewhere beneath the solid, beneath the table that the hand approaches and is turned back from, beneath the atoms that are mostly distance, beneath the fields that are the only substance left, there is the trembling, the perpetual, irreducible activity that the most precise science in history has confirmed at the deepest level available. Not the trembling as disruption, the trembling as what the ground is, the activity that cannot be switched off, the zero-point motion that remains when everything that can be removed has been removed. The traditions said the same thing from inside. They said, The state you are trying to hold is not the ground. The ground is what is there when you stop trying to hold anything. They did not use the language of fields and excitations. They used the language of sky and clouds, of rivers and their source, of the face you had before you were born. Different words, the same shape. The solid world does not require the trembling to stop in order to be solid. The solidity was never what it seemed. It is patterns held in place by forces that are themselves patterns in fields, that are themselves excitation, all the way down. And the held patterns persist. They persist because they are the modes that fit their boundaries, the standing waves that the geometry allows. Not because anything has frozen them, because they are in this moment in resonance with themselves. You do not need to hold the morning still. The morning was always already this. The opening that slipped by noon was not taken from you. It was the ground briefly visible through the habits of the day. The ground did not move when it disappeared from view. The ground is there now. It has always been there. It was there the whole time. There is no still place to arrive at, and there never was. Only the trembling, all the way down, and the long quiet trust that the trembling was the ground that held you the whole time.